All right, welcome to 4.1, introducing the periodic table. This is going to be just a short introduction of the periodic table. I'm not really going to go deep into it. We will further our research and our investigation of the periodic table later on in the semester. But we just want to get a cut and dry idea as to how this thing is arranged and why certain elements are placed where they are. So let's look at when the table was first introduced. It was introduced by this gentleman by the name of Dmitry Mendeleev, and he was a Russian. And in 1869, he proposed this idea of organizing the elements. At that time, there were 50 or so elements that were known to man, and every single year there was about one more popping up. So there are a lot of elements, and we knew that these things were the fundamental building blocks of matter, so they're obviously really important. So trying to find a way to organize these things was going to be important. And there's Mendeleev. He looks pretty frazzled in this picture. And he came up with an idea called periodic law. He said that if you organize stuff in the right form or fashion, what you can find is that materials will exhibit repeating patterns. And you can organize these materials in such a way that these repeating patterns become ever more evident by your organization. So he used really two big organizational skills. First of all, he organized the elements by their weight. He put small, tiny little atoms on one side of the table and big, huge atoms on the other side of the table. And then he also organized them by their properties, things that reacted alike, or things that were solids at room temperature, things that were gases at room temperature. He put them in their own little sections. And so now he's organizing these elements based on their properties, and this is the idea behind periodic law. And this is actually Mendeleev's first periodic table that he had come up with. And I think you would probably agree it looks nothing like our current periodic table right now. But if you take a closer look, you'll be able to recognize some things. Hopefully you're looking at that periodic table I gave you at the beginning of class today. So if you look at the far left, you're going to notice that hydrogen and lithium are kind of stacked on each other. And our periodic table does the same thing. Hydrogen is stacked on lithium. And both of those things are on the far left side of the table. If we kind of move to the right, we're going to see some other ideas that are kind of similar. We'll notice that this column of elements right there follows kind of a pattern that we see on the modern periodic table. Beryllium is not on top, but it is furthest to the left on our table. And it is followed by boron, carbon, nitrogen, oxygen, and fluorine. And then sodium is actually underneath it. And we see that kind of repeating idea. So what Mendeleev was playing on here is that he saw these elements have similar properties. So he characterizes them and he bundles them together. And then he sees that these elements have similar properties. So he bundles them together. That's his idea of periodic law. What's really kind of cool about Mendeleev's table is that he actually predicted the existence of some type of materials that they hadn't even found yet at this point. And I'll highlight one, for instance, right here. Here's a question mark right at that guy. And they knew that the mass of this material, he quantified it as about 45. We won't get into units yet. But he didn't know exactly what that material was. Well, it turns out, if you look at your periodic table and you find a number that's close to 45, actual decimal number, not a whole number, you will notice that scandium has an atomic weight of about 45. They didn't know about scandium back in 1869, but he actually predicted it by finding a hole in the periodic table. He said, well, I think this thing exists, we just really haven't found it yet. And lo and behold, yep, we found it. Just it took us a little bit of time. So anytime you see a question mark on his table, that kind of corresponds to another element. 68 most likely would be something like gallium. All right. So let's skip ahead then, about 150 years or so, to our modern periodic table. So this is what you're now familiar with. And you have a pink periodic table. You can use that periodic table on worksheets. You can use that periodic table in the lab. But I will be giving you your own periodic tables, quizzes, and tests to work on. So there won't be any chicken scratch on those periodic tables. But I do encourage you right now to write the following stuff on the periodic table that you have, the pink one. All right, so how's this thing laid out? Let's start on the left. First of all, hydrogen. That's the first thing that we have to address, is kind of a rogue element. Hydrogen is a gas. It is the only gas that is located on the left side of the periodic table. It is placed over on the left side of the periodic table because it has the same number of electrons as all of the elements in that column. And when I say the same number of electrons, I mean the same number of outer electrons. Those are called valence electrons. Very important electrons that we'll talk about in Unit 6. Okay, so that's why it gets displaced in the leftmost column. So we have to introduce that right away. Besides hydrogen, everything else on the left is going to be known as a metal. So our purple column over here on the far left, we actually have a special name for these guys. We call these the alkali metals. They're very, very reactive metals, and I'll show you a demonstration a little bit in the future between two of these metals, sodium and potassium. A pretty cool demonstration between those, again, when we get to Unit 6. So those are the alkali metals. The second column that we have, the blue column down here, these are known as the alkaline earth metals. Again, these are metals. You might say calcium is not a metal, but we use metal a little bit differently than you think of metal. You probably think of metal, you think of copper and iron. When we think of metal, we're thinking of something that allows kind of electricity or electrons to flow in between the solid material. Okay, and that doesn't have to always be a copper or an iron for that to happen. All right, so that's the blue and the purple. Let's go to the yellow now in the middle here. These, the most abundant section on the periodic table, are called transition metals. They are known as transition metals because they can actually take their electrons and they can like switch them. So they're not switch them, but they can move them around. That's a better way to say it. So they can take their electrons and they can move them further away from their nucleus or closer to their nucleus. And because they can do that, it gives them a lot of really cool, interesting properties. And we recognize a ton of the transition metals, right? Copper and silver and gold. Interesting that they're all in the same column, right? The Olympics were just recent, right? First place is gold, second place is silver, third place is bronze, which is primarily copper. I wonder if that's why they stacked them in that order, because of the Olympics. No, that's not why. It just is the way it is. Okay, so we have the yellows, we have the blues, we have the purples. These greens are also known as metals. Okay, these greens usually get a very ambiguous term. They're just known as the other metals, is what we'll call them. The other metals. All right, the brown dudes. These guys are known as semiconductors, and thank your lucky stars that we have semiconductors, because they are the things that allow your computers, your iPhones, your Samsung Galaxy S, your tablets, new cars, anything that has electronics on it. It is the semiconductors that you see on the periodic table that allow these babies to work. Those are semiconductors. All right. Then if you'll notice, we actually have what I call the stair step, and I'm going to draw in the stair step here. We have a stair step. It's a little zigzag stair step that actually separates out. This is what I would call our separation line. The stair step separates out the left side of the periodic table from the right side. When I talk about the left side of the periodic table, I am talking about everything to the left of the stair step. It seems to be a little bit unfair, because the left side then is a whole heck of a lot bigger than the right side, but that's just the way it is. I'll be honest with you though, the elements on the right side of the table are used almost more than the ones on the left side of the table, especially when it comes to your body chemistry. All right, so these guys on the right side of the table, we got a couple of important names. They're all called nonmetals. All of them are nonmetals. These guys here are known as the halogens. Boy, that's a horrible color. Let me get a different one here. These guys are the halogens. They are gases at room temperature. All of them are gases at room temperature, with the exception of bromine. Bromine is one of two liquids on the periodic table, the other being mercury. There's one other blue element on the periodic table, and that is gallium. And you'll see some periodic tables that call it a liquid, and some periodic tables that don't. Gallium is awesome stuff because the material will actually melt in your hand. Your hand is warm enough to melt the gallium, but normal room temperature is not. So typically you're only going to see two liquids at room temperature on the periodic table. Those two would be bromine and mercury. A little interested why cesium and francium over here are blue. I would kind of negate that. All right. The last column of utmost importance is this column over here, the royal column known as the noble gases. These dudes are very noble because they are unreactive. They do not play with others. They do not form molecules or compounds. So when you're talking neon, you're only looking at a neon atom. It's not going to combine with carbon or germanium or manganese or anything else. It's just going to be neon. And those are the noble gases. All right, so there we go. From left to right, those are the identities of the elements. Now you may be asking, well, we missed a whole bunch of them, Mr. Kornick. We missed the guys on the bottom. Yep, these dudes down here. Now we aren't going to talk about these as much, but they do have names. These are known as the lanthanide and the actinides. Okay, the first ones here, these are the lanthanides. And the top ones are the actinides. The actinides. And again, we don't talk about those a ton, but there are some important elements down there, probably namely that guy right there, right? U, that stands for uranium, and we know that there's a lot of uses for uranium. All right, last thing. We are going to refer once in a while to columns or periods on the table, and we also can call them families and groups. When you see something that's vertical, that lies up and down like this does right there, we refer to that as a column. That should make sense. And we also refer to it as a group. Reason being is that elements that are in the same group have similar properties. Lithium and sodium and potassium have similar properties. Hydrogen actually does have similar properties to those other elements, okay, even though it is a gas at room temperature. So we call it a column and a group in the vertical column. And, you know, over here with copper, silver, and gold, the column, a group, vertical column. Now, we can do the same thing with our row. Okay, instead of calling that a column, we call that a row or a period. Or it's got one more word, we could call it a family. Alright, and we'll also notice, again, once we get to Unit 6, why all the elements in a row or a period have similar properties. Okay, that's just a quick introduction to the periodic table. Be sure to be studying your elements. You see that I do have that Quizlet up on Edmodo. Give that a shot a couple of times tonight. That should help you try to square away the Fantastic 50.